Let's look at some examples how to use these basic rules. Okay, so this is the example that the limit x approaches -2 of the function 3x squared plus 5x minus 9. So this is the sum of several functions, right? So we can split into several parts. We can take the limit x approaches -2 of 3x squared plus the limit x approaches -2 of 5x minus the limit x approaches -2 of 9. So we use the fifth law, okay? We can split into several parts, then take the limits for each part. Then we can take the constant outside, right? This is the 3 times the limit x approaches -2 of x squared plus 5 times the limit x approaches -2x minus the limit of 9, the limit of constant would be the constant itself, so it's equal to 9. So here we can use other laws. So this would be 3 times the limit of x squared when x approaches -2, it's -2 squared. So don't forget the parentheses for the -2. Then plus 5 times x, the limit of x when x approaches -2, which is -2, minus 9. So if you do the calculation, it would be -7. So this is the first example. The second example, the limit x approaches 2 of, okay, so here let's change the variable to be t. T approaches 2. 2t plus 1 over t squared plus 1. So this is the quotient, right? This is the rational function, which is the quotient of the polynomials. So we can use the basic law for the quotient of two functions, so which is the limit t approaches 2 of 2t plus 1 over the limit t approaches 2 of t squared plus 1. So before we do the further calculation, let's go back to the first example. So you can see that the first example, which is the limit of a polynomial, right? Let's compare this one and this one. So you see, for the limit of a polynomial, you just plug in x equals -2. You will get this one, right? Then you have your result easily. So this gives you the idea is if p is a polynomial, suppose p is a polynomial, p of x is a polynomial. Then the limit x approaches c of p of x, which is just plug in the numbers. Right. This example tells you this fact. We will not prove that, okay? So this is the fact for the polynomial. It's very easy. You just plug in x equals -2, right? Because the limit equals the f values at x equals -2. So this kind of function, very good function, right? So now let's look at this, the limit. The top is the limit t 2t plus 1, which is also a polynomial, right? So we can see this one is, we plug into 2 times 2 plus 1 over the denominator, which is the limit t squared plus 1. T squared plus 1 is also a polynomial, so you can just plug in the 2 directly. So it's 2 squared plus 1. So at last, you will get 5 over 5, which is equal to 1. This limit is 1. So this example tells you that if you have a rational function Rx, which is equal to a polynomial p of x divided by another polynomial p of x, this is called the rational functions. Right? From the pre-calculus, we know that the rational function is the quotient of two polynomials. Then the limit, so here p and q are polynomials. Then the limit x approaches c of Rx, which is the limit of p of x approaches c over the limit x approaches c of Rx, which is, because p and r are, sorry, this is q, not r, q of x. P and q are both polynomials, so you just plug in the numbers from the first example. We know we have this fact, right? Plug in the numbers, and you can get your result.